Hi, I'm going to demonstrate how we can verify that two triangles are similar through transformations. So I have triangle DEF, and my goal is to map triangle DEF onto triangle ABC using a series of transformations, rigid transformations and a dilation. I'm going to start with a translation, and I'm going to translate one vertex of triangle DEF onto the corresponding vertex of triangle ABC. And I'm going to pick vertex D. And I know that the corresponding vertex is A because these angle measures are the same. So I'll choose the transform tool. I'll pick translation. And I'm going to use the translation vector that takes D onto A. Now I have to select some objects that I want to apply this transformation to. So I'm going to use the rectangle tool to select triangle DEF, and I'm not sure that I got point D, so I'm just going to shift and select that. And now I'm going to apply my translation. Perfect. So we can see that now we have an image of the original blue triangle here with point D exactly lying on top of point A. The next thing I want to do is I want to rotate this triangle so it's in the same orientation. And that means that this segment here will lie exactly on top of segment AB in the green triangle. So to do a rotation, I'm going to need the measure of this angle so I can figure out how much to rotate it. And I don't know what that is, but luckily I can use a Desmos tool to figure that out. So I'm going to click on the angle tool, and it says choose a point, one leg, and I could choose a point right on the side of the triangle, but I'm actually going to choose this vertex so I don't want to make an extra point because it gets kind of messy. Then I'm going to choose point A, the vertex, and then my other leg or side of the triangle is this one. And again, I'm just going to go all the way to the vertex. So I'm measuring this angle, and the angle measure is here. It's 25 degrees. So that's how much I want to rotate by to align these triangles. So I'm going to define a new transformation, a rotation. And the center of my rotation is going to be this vertex. This vertex is key to the whole process. And for my angle of rotation, it's going to be 25 degrees. Oops. And what I know about Desmos is that if I put 25 degrees, it's going to rotate 25 degrees counterclockwise, but I want it to rotate clockwise. So I'm going to specify that that's a negative 25 degrees because that's how I tell it to rotate clockwise. And again, I need to select some objects. So I'm going to select and I'm pressing shift so I can select multiple objects, the vertices, the sides. Okay, hopefully I have everything selected, and I will apply my rotation, and I can see it swings clockwise 25 degrees and lands just about on AB. Maybe I should have said 25.2 degrees or something, but I think it's close enough to see what's going on. Okay, and you can see that this side of the blue triangle looks like it is parallel to this side, which makes sense because these angles here, 81 and 81, are congruent, and 55 and 55. I know that from the original triangle. So all that's left is to do a dilation. For a dilation, I know I'm going to need a scale factor, and I'm going to use these side measurements to find my scale factor. So I'm going to use the calculator. Oh, look, I already did it. So I'm choosing this side length, 7.95, divided by this side length, 4.61, and I see that gives me a scale factor of 1.7245. Okay, if I want to kind of test that this makes sense, I could try a different pair of corresponding sides. I could say I'm going to choose 11.32. That's the length of side AB. And the corresponding side of the blue triangle, side DE, has length 6.58. And I see, okay, 1.72. So they're a little bit off because of rounding, but I can see that 1.72 is probably going to work pretty well for the scale factor. So I'm going to choose the dilation tool. For the dilation, once again, I need to choose a center point, and that's my favorite vertex right here. And my scale factor is going to be that 1.72 that I just calculated. And now I want to select my blue triangle here, sides, vertices, and you may end up accidentally selecting parts of the green triangle. That's easy to do. That's okay. So I'm going to apply that dilation, and beautiful. So I can see that I've mapped triangle DEF onto triangle ABC, and I did that with a translation, a rotation, and a dilation. And since I was able to map triangle DEF onto triangle ABC by a series of rigid transformations and a dilation, I know that triangle DEF is similar to triangle ABC. Ta-da!